What if I told you that two particles, separated by vast distances, could instantaneously affect each other's behavior? Welcome to the world of quantum entanglement. This is not a concept from a science fiction novel, but a fundamental principle of quantum mechanics, the branch of physics that governs the behavior of the smallest particles in the universe. Quantum entanglement is a phenomenon that has puzzled, intrigued, and even bewildered scientists for decades. Imagine this. Two particles are entangled. They could be light years apart, yet, if you measure one, the state of the other changes instantaneously. It's as if these particles, no matter how far apart, are connected by an invisible thread, communicating faster than the speed of light. Sounds impossible, right? Yet this is precisely what quantum mechanics predicts, and what countless experiments have confirmed. It's a concept so counterintuitive, so against our everyday experience that it's hard to wrap our heads around it. But it's real. It's science. This strange phenomenon was first predicted by the mathematics of quantum theory in the early 20th century. Yet it was so bizarre that even the pioneers of quantum mechanics, including Albert Einstein, Niels Bohr, and Erwin Schrödinger, had heated debates about its reality. Einstein in particular was deeply uncomfortable with the idea. He famously referred to it as spooky action at a distance, a phrase that has since become synonymous with quantum entanglement. He believed that there must be some hidden variables that quantum theory didn't account for. Yet, time and again, experiments have shown that quantum entanglement is a reality of our universe. It's a testament to the strangeness of the quantum world, a world that operates under laws so different from those we're familiar with in our everyday lives. So buckle up as we dive into this enigma of physics. We'll explore how quantum entanglement works, how it's being used, and what it might mean for our understanding of the universe. Quantum entanglement, a phenomenon so bizarre even Einstein himself called it spooky action at a distance. To comprehend quantum entanglement, we first need to delve into the quantum world. In the quantum realm, reality as we know it takes a back seat. Here, particles can exist in multiple states at once, a phenomenon known as superposition. Imagine a coin, spinning in the air, that's both heads and tails simultaneously. That's a crude analogy for superposition, but it gives you a sense of the bizarre quantum landscape. Don't try to pin these particles down to a single state, though. The moment you observe them, they choose one. It's like our spinning coin suddenly landing on heads or tails. This is the observer effect, another mind-bending principle of quantum mechanics. But here's the real kicker. Particles in the quantum world can also be entangled. This means the state of one particle is intrinsically linked to the state of another, no matter the distance between them. It's as if our spinning coin had a twin, and the moment one lands on heads, the other lands on tails instantaneously. This isn't some fanciful theory, it's been experimentally proven. Quantum entanglement is a cornerstone of quantum mechanics, a field that's revolutionized our understanding of the universe. Yet despite its proven existence, quantum entanglement remains paradoxical. After all, how can particles possibly communicate faster than light? How can the state of one particle know the state of another, regardless of the distance between them? These are questions that continue to perplex scientists. Quantum entanglement is a heady mix of mystery, paradox, and proven fact. It's a testament to the richness and complexity of the universe. It challenges our conventional understanding of reality, demanding that we view the world not as it appears to our senses, but as it truly is. A world where particles can be in two places at once, where observation determines reality, and where entanglement creates instantaneous connections. In this realm of the tiny and the intangible, quantum entanglement isn't just possible, it's inevitable. Now that we have some grasp on the quantum world, let's explore how quantum entanglement actually works. Quantum entanglement, often described as spooky action at a distance, is a phenomenon that might seem to defy common sense. But in the world of quantum physics, common sense is often left at the door. So how does this entanglement process occur? Picture two particles, let's call them Alice and Bob. These particles can be anything, electrons, photons, you name it. When Alice and Bob are created together or interact in a particular way, they become entangled. This means that the state of Alice is directly related to the state of Bob, no matter how far apart they may be. This entanglement is established through quantum mechanics, a branch of physics that describes the world at the very smallest scales. Quantum mechanics allows particles to be in multiple states at once, a phenomenon called superposition. When Alice and Bob are entangled, they are in a shared superposition, a blend of states that directly relate one to the other. Now, here's where it gets really interesting. If we measure Alice, forcing her out of superposition and into a definite state, Bob immediately assumes the corresponding state. This happens instantaneously, faster than the speed of light, which seems to violate Einstein's theory of relativity. But remember, this is the quantum world, where the usual rules don't always apply. It's important to note that this isn't some kind of telepathic communication between Alice and Bob. It's not that Alice sends a signal to Bob. Rather, it's as if they are two sides of the same coin, their states intrinsically and instantaneously connected through the strange magic of quantum mechanics. So that's the core of quantum entanglement. It's a mind-boggling concept, one that challenges our understanding of reality. But it's also a fundamental part of the quantum world, a world that we are still striving to fully understand and harness. Once entangled, these particles become inextricably linked, their fates intertwined across the cosmos. Imagine the possibilities if we could harness this spooky phenomenon. Well, we're not just imagining. We're actively exploring the applications of quantum entanglement, and the results are nothing short of revolutionary. Consider quantum computing, for instance. Traditional computers use bits, which are either zeros or ones. However, quantum computers use quantum bits, or qubits, which can be both 0 and 1 simultaneously, thanks to the magic of quantum entanglement. This means a quantum computer can process a vast number of computations all at once, potentially solving complex problems in seconds that would take even the fastest supercomputers millions of years to crack. Google's quantum computer, Sycamore, has already demonstrated this potential, solving a calculation in 200 seconds that would have taken the world's fastest supercomputer 10,000 years. But it's not just about computing. Quantum entanglement could also revolutionize communication. Quantum teleportation, which may sound like something out of a science fiction novel, is an emerging field that relies on entangled particles to transmit information instantaneously, regardless of distance. It could herald a new era of ultra-secure, super-fast communication. Moreover, entangled photons could transform medical imaging, enabling us to see inside the human body in unprecedented detail. Researchers are even investigating the possibility of using quantum entanglement in the fight against climate change by developing more efficient solar cells. The most exciting part? We're only scratching the surface of what's possible. As we delve deeper into understanding quantum entanglement, we continue to discover new ways to apply this extraordinary phenomenon. Universities, tech giants, and governments worldwide are investing billions into quantum research, not only to understand the fundamental laws of the universe, but also to drive the next technological revolution. As we continue to unravel the mysteries of quantum entanglement, who knows what new frontiers we might unlock.